Welcome everyone, and today I'm going to be talking about unpacking Compose multi-platform accessibility. So before I jump into that, hey, I'm Colin Marsch. I'm an Android engineer on Cash App, and while I don't work on Compose multi-platform too much day to day, I am involved in some Kotlin multi-platform efforts at Cash App. On the next slide, actually, I'm going to sort of compare and contrast some of these things just to give a bit of an overview of these two different multi-platform uh, paths forward. And at Cash App, I'm also part of our accessibility working group, helping to ensure that Cash App is accessible for all of our customers. So firstly, what is Compose multi-platform? As I mentioned, I do a bit of work using Kotlin multi-platform, and I sort of want to compare these two together to give a good example for folks here. So Kotlin multi-platform can generally be thought of as shared logic. It allows you to have a Kotlin shared code system where you can write your business logic there and sort of more of the inner workings or the backend portion of your application, if you might call it that, and then share that Kotlin code on multiple platforms like Android, iOS, web, etc. I will specifically talk more about Android and iOS just to keep things on the mobile side for this presentation. But yeah, Kotlin multi-platform focuses on shared logic. Then if we go over to the other side on Compose multi-platform, this focuses more on shared UI. It allows developers to build Compose UI uh, designs using their composable functions. You might be familiar with that from native Android development using Compose UI. This would use the same APIs and just allow you to ship that UI to Android and iOS platforms from one single code base. So now how is this related to accessibility? Firstly, whenever developers are working on UI in their apps, accessibility should be something that is front of mind, as this is the time where you have the most control over the experience that your customers are going to see, no matter what assistive technologies they're using or what their ability levels are like. As well, since Compose multi-platform uses the same APIs that Android Compose UI natively uses, there is a plethora of different accessibility features available there that you can use to enhance the accessibility of your application, particularly if you're building some complex custom UI, maybe doing something like creating your own custom view style things and making things a bit more unique for your app. So as we jump into some accessibility features of Compose multi-platform, I do just want to briefly talk a bit about testing iOS accessibility using or on apps that are built using Compose multi-platform. Um, so as a bit of background, Compose multi-platform right now is in the beta stage, and the iOS accessibility is in the early stages of development, according to some documentation put out by JetBrains recently. So there are still some changes that may be coming to the way iOS accessibility functions in Compose multi-platform, but this is some configuration options that I found helpful to set up when testing the accessibility on iOS simulators myself. I suppose a caveat there is that you will need a Mac computer to build and run the iOS app from your multi-platform project. On the uh, testing side of things, the Compose structure through Compose multi-platform creates an accessibility tree that is synced to the iOS app to allow the iOS assistive technologies like VoiceOver to see all of the hierarchy of information, like the content descriptions and other information for the elements on the screen. So if you create your Kotlin multi-platform project using the plugin in Android Studio by JetBrains, just called Kotlin multi-platform, you'll get a iOS main module with a main view controller Kotlin class that has pretty much just this one line in it, which is a declaration of the main view controller that is corresponding with this Compose UI view controller. So this is sort of just the entry point into the Compose UI of your app on the iOS side. But what's interesting here for our case is this configuration option called Accessibility Sync Options Always. This allows the Compose Multiplatform framework to ensure it is updating the accessibility tree on iOS when anything changes at any time during the app. So if new elements are drawn, the tree will be updated to ensure that their accessibility information is also reported in the accessibility hierarchy tree in iOS itself. So you'll be able to detect that if you're testing your iOS accessibility using the developer tools through Xcode. In particular, the accessibility inspector is one that is the most helpful here. So accessibility inspector allows you to sort of simulate what VoiceOver, the screen reader technology on iOS, would see if you were using this on a real device. Without this configuration option set, the iOS accessibility tree right now is only updated if there is a connected assistive technology. And on an iOS simulator, this flag will not be set on, so you won't be able to see these accessibility changes come through real time if you are just using the accessibility inspector, as the simulator sort of behaves a bit differently than a real iOS device would. So this was just a helpful option to be able to test this out on a simulator properly. And now to jump into some accessibility features of itself of Compose Multiplatform, I want to start with what I'm calling app scoped features. These I'm sort of thinking of as features that are higher level than a individual component in your UI. So these would apply to your entire app as opposed to another feature which might apply to, for example, an individual image or text. First one of these I want to talk about is font scaling. Font scaling is a common accessibility setting that customers can enable on their devices on Android or iOS to change the size of the font that they see across all the applications on their phone. So you might be able to increase the size if you are a bit lower vision or want to have that as more of comfort for you to be able to clearly see the content on your apps visually. You can also shrink it as well if that is the preference of the user. So here is just an example screenshot of the Compose Multiplatform sample app by JetBrains with the scale turned up to the higher settings on the right side. So you can see that the text is increased in size and just makes the text bigger. One of the problems, though, that can come up during large font scaling is cutoff text. So in this example screenshot, you can see the repository row here used to say Metropolitan Museum of Art, where this painting was held. However, if the text is increased in size and we only had one line of text content here, I sort of just altered the code here a bit. So there's not a real issue in the sample app, don't worry. But the Metropolitan Museum of Art string will be cut off a bit and we won't be able to see all that content. So this is one common example of an issue that can come up when you're running into these large font scaling test cases. This is something that you'll have to keep in mind if you're using Compose Multiplatform or just regular native UI. So it's not super specific to Compose Multiplatform, and I won't delve too deep into the resolution here, as it is a common mobile problem that could come up using different UI frameworks. As well, just briefly wanted to touch on color contrast, which is another high level feature that is something to keep in mind when building a application. You can see here in these two screenshots, there are various background colors corresponding to the text that is laid on top of it. One of these is a bit harder to read due to the contrast being low between the text color and the background color. I'm sure you can tell which one is which, but the one on the left has a very low contrast, and therefore you can't read the text as easily. So setting up the colors of content that is laid on top of each other is especially important for any application you're building and should be kept in mind during your Compose multi-platform development as well. So now to get more specific on element scoped features, again, these are ones that are specifically applied to a single UI element, like an image or text. These are where Compose Multiplatform does provide APIs that allow us to change the accessibility functionality of the elements in our app. So I want to go through a few of the most popular or sort of important features here. Firstly, content descriptions. This is a field that just allows developers to supply custom text to describe an element more clearly to customers who are using screen reader technologies like TalkBack on Android or VoiceOver on iOS. Here, the common example that comes up will be to describe images. Images, especially if they contain information about the application, are something that is inaccessible to people using screen reader technologies if they have lower vision and are not able to determine visually what kind of information the image is trying to say to them. So, for example, here we could describe an image with a content description and say a field of sunflowers. So then when a customer uses a screen reader, they will highlight the image using their screen reader and would be read back to them. It would say a field of sunflowers, and they would be able to understand what was on their device's screen. So here is an example screenshot of the sample app again. You can see here from the green boundary box, we are highlighting the image here of this painting. At the bottom of the screen, listed is the content description. It says the flower girl, which is the name of the painting in this case and describes what the customer is seeing on their phone. This is something that works the same, this API, as Compose UI on native Android, and with Compose Multiplatform functions both on Android and iOS. Merging Descendants is a more complicated accessibility API, I would say, and I think it makes a bit clearer if we just jump to the code now and take a look at this. So if you see here, we have a small composable column with an image and text within it. If we did not merge the descendants, which is the default here, when using a screen reader, we would experience the behavior where it would highlight the image first, read us out the content description, wave emoji, maybe it looks like a picture of a hand waving, and then highlight the text next, which says hello. So this would be okay, but from the context here, it seems that these two UI elements are related, and we probably want to group them together, as that'll provide more context for the customer to hear that all as one unit. So on the parent of these two elements, the column in this case, we could enable the merge descendants flag. In this case, we would see our screen reader highlight the entire column instead of the individual image and text. Then when it read things out to us, it would read out all together, wave emoji, hello, just to allow us to have a better understanding. Okay, yeah, this image and text are all related together. So as some examples here, on the left side, there is a screen recording of the default behavior where the details at the bottom of the painting are not merged. You can see that each row is highlighted individually and read out individually by TalkBack. On the right side, you can see that just the entire block of text is highlighted together, and this is where we have merged all of this content together as into its parent. Custom actions is the next accessibility feature I wanted to talk about, and is one that is commonly used for gestures that are a bit more complex or impossible to use to perform if you're using certain assistive technologies. Things like keyboard access or switch access are assistive technologies that allow users to navigate through the hierarchy of applications using a sort of button system, and that will not allow them to take actions such as swipes or pinch to zoom and things like that. So, common example here I like to think of is in an email app. There's often a behavior where if you swipe left or right on your email, you'll move it to the trash. So this behavior of swiping left and right is something that might not be accessible for our users. And we can use a custom action to allow them to still be able to take that behavior in the app and delete their emails. So here we have a text composable, just as Compose Multiplatform. And specifically what we want to look at in this case are the custom actions here. So this is can be supplied as a list if we want to have more than one custom action. But each custom action here contains two properties, a label and an action. So the label in this case is activate. That is just the name of the action we want to convey to the user what it will sort of do. And the action is a lambda, which will be run when the customer takes that action. So in this case, for activate, I just sort of put a comment here, but we could have any behavior in there we want to activate this text. I do want to mention now that the custom actions value we're setting here is part of the semantics modifier on the text composable. This is something that is very standard among many of these accessibility features. If you noticed on the previous slides as well, those were using the semantics modifier for those cases as well, even though I didn't mention it on those slides. So now if we look at the screen recording for this feature, you can see if we tap with 3 fingers on the device, that is the default behavior to open the talkback menu on Android. This shows the actions menu, and in there we have activate, which is the action that we just defined in the previous composable code. So this is also a function on iOS using VoiceOver, and Compose Multiplatform using the API that we just discussed will work as expected on both platforms, Android and iOS, supplying you with the accessible behavior equivalent on iOS as well. Heading is a relatively straightforward accessibility feature that allows you to specify an element as a heading if it's in a sort of title role on the screen. One example here I like to think of is on a news app, you might have sections that are something like local news and then a bunch of articles, and then national news, which a bunch of articles, and world news, which a bunch of other articles. You could mark each of these as headings, like local, national, and world, and this would allow customers to skip between them. So there's a feature in TalkBack and VoiceOver on both platforms that allow you to navigate based on headings, so you don't have to look at all the content inside it. Without marking these as headings, customers would have to go through every single article in the local section to get to the national section. And then to get to the world section, have to go through every single article on the national section. So this could save them some time by being able to navigate quickly and skim through the page to the headings. So here, just looking at a text composable, we can see the pretty straightforward use case here. We call this heading function in the semantics modifier again on the composable, just to set that we are a heading in this case. So in our recording here, we can see when we highlight the title text right underneath the painting, it reads out to us the Flower Girl heading. You can see on the bottom of the screen there. Might be a bit small text, but I put it on the side as well. The Flower Girl heading, just denoting that that is what this element is a heading. Role and the next feature I want to talk about are ones that are more likely to be used only if you're building very custom components in your applications. For the most part, all of the composables that you'll use in Compose Multiplatform, the basic ones at least, like button, text, anything else that sort of baked into the material components will have these values already set properly for them. So role is something that allows you to customize what kind of thing a UI element is. So if we look at the code here, we can specify via the semantics modifier again, the role of a element. So here we're saying role of this element is a button. There's many other roles you can choose from. It can be things like switch or checkbox. This sort of just helps convey to your user what the expected interaction pattern might be. So for a button, it's probably something they can click on. If it's a checkbox, then it's something that will be enabled or disabled depending on whether you have interacted with it before. This allows you to customize that behavior, so it's more easy to understand what the current state is. And as I mentioned, this role is automatically set for all of the basic material components in Compose Multiplatform. So this is maybe a less used feature if you're just using the standard components and not doing anything super out of the box. Like for example, a composable button will already have the button role properly set, and composable switches will also have their roles properly set. State description as well is something that is more so just used for a custom case. In the state description, that allows us to provide our customers with a custom string that will be read out to just let them know what state the UI element is in. So, for example, the checkboxes I mentioned could be enabled or disabled. That would be something that would be already baked into the system if you're using those standard Compose components. But if we have something that we're building a little custom, we might want to supply our own state description. So in this case, hidden is a state description text I am setting here, and that will let customers know that in this case, the Compose Multiplatform text is in the hidden state, whatever that might mean for your application. So you can use any string here just to represent the state that the element is in. Could be on, off, anything that's up to you. So to showcase this one, again, on the title text, the flower girl, we can see it reads out hidden, the flower girl, reading that state description first, and then the content description, which in this case is just the text content on that title. So now I want to briefly talk about the takeaways from this presentation. Firstly, Compose Multiplatform accessibility is almost identical to Android Compose UI native accessibility. So if you are already familiar with Android native Compose UI accessibility, you are probably 99% of the way there to Compose Multiplatform accessibility, as all the APIs are the same. And the behavior is what you should expect to see from the Android Compose UI accessibility APIs. That is not to say that everything will be working as expected, however, as the iOS accessibility support is still in the early stages of development. According to JetBrains, there are some known bugs in their issue tracker. One of them in the issue tracker I actually ran into during testing of this presentation, specifically around the focus order of the elements on the screen. So for example, in this painting sample app, the text rows beneath the painting were not focused in the order that would be expected by a customer. Ideally, it should be sort of just down the list in that order, but it jumped around in a couple cases where this is something that will likely be worked on in the next couple releases of Compose Multiplatform and fixed up by the JetBrains team. So because of this, and just for general multi-platform development, I would encourage everyone to test on both mobile platforms if you're building an application using Compose Multiplatform, especially as it is a new technology and you want to ensure that there are that it is accessible for customers on both of your platforms, especially as we try out some of these APIs. There may be behavior differences in TalkBack and VoiceOver on Android and iOS that might encourage you to do things a bit differently in your multi-platform setup, just to ensure that sort of the platform standards of these accessibility screen readers is maintained as customers on Android and iOS would expect, in line with the other applications on their device. And that brings me to the end. So thank you. And I am happy to answer a couple questions.
All right. Thank you, Colin March, for all of your presentation. I think that it was really nice to hear from you, hear about Compose Multiplatform. Um, and if there are any questions, we'll be delighted to hear them. I think there is a for information from Robert Hanley. If you want to check, role is most commonly used in fire, selectable, or toggleable when remediating a radio button or checkbox by wrapping it in a row with a programmatically associated text label. What do you say about it, sir? Do you agree with it? Okay.
Yeah, I think that makes sense. Um, Reading a checkbox, wrapping it. So yeah, I think the sort of containerizing the like radio button with more content to link them together, as since you'll probably only want to choose one or more of those. That makes sense.
Okay.
Thanks for pointing that out.
And another question, another contribution from Mr. Henley. Does Compose Multiplatform offer any means of setting iOS accessibility hint? What do
So
you say about
this,
it?
yeah, I'm familiar. I think the iOS accessibility hint is a bit different than the Android standard APIs. So I haven't seen a way of doing this particularly in Compose Multiplatform, as the APIs right now match exactly to the Android Compose UI APIs. Um, so at the moment, I'm not aware of this functionality, but yeah, it is would be something that's good to have, and it might be there, and I'm not aware of it.
I'll agree with you. I mean, Compose Multiplatform tries to develop not platform specifically things. They want to combine things up, but iOS will always show problems with Android. They'll be not 100% compatible as much as Flutter or React Native. But I think if Compose Multiplatform will stabilize and start to develop their own API implementations, I think it might be a opportunity or option for
Mhm.
us.
Yeah, and as well, like since the iOS accessibility support is relatively new in Compose Multiplatform, I think it's just in the most recent version that it was actually added. So the uh, functionality there will likely be expanded.